Everyone, and a warm welcome to this media event. Thank you very much for coming. So I'm very much looking forward to spending more time working with our partners in APAC as we help people to create innovative products based on our technology. So over the past few years, as I'm sure we've all noticed, there's been a transformation in computing, and we've seen a move away from the sort of one-size-fits-all PC model to really a new paradigm, a world of rapid innovation in mobile computing devices, and the blurring of the boundaries between the consumer and enterprise worlds, and it's driven by new applications, new use models for consumers, and of course the move into the cloud. And ARM has been really at the forefront. Our low power technology, our partnership business model has been at the forefront of driving this transformation. So, without further ado, I'm very pleased to hand over to Simon Segars, who is going to share some more with us on this topic. Simon is the Executive VP and General Manager of the Processor and Physical IP divisions at ARM. So, Simon, over to you.
Thank you, Graham. Thank you very much.
Thanks, Graham, and good morning, everyone. Packed room. There are a few seats if you want to make yourselves comfortable. Thank you for joining us all at our event this morning. Appreciate it's the start of the day and the start of what's going to be, I'm sure, a very, very busy week for all of us. I'm very excited to be here and looking forward to seeing what ARM and ARM's partners have achieved over the last year and what's on display this week. Now, Computex is traditionally about PCs, but we think that the world of how the world computes is actually changing, and we're moving to a much more mobile driven world. And so that's why ARM has a presence here at Computex. This is actually our 5th year at the show, and each year more and more of the devices are looking like portable computers, and computers that you once upon a time wouldn't recognize. I'm going to talk a bit about that this morning, what we see the trends are for computing, and how we see the opportunity over the next few years. Now, ARM has been around for just over 21 years, and in that time we've seen a huge transformation in what computers look like and in the way that people communicate with each other. I bet everybody in this room has at least one mobile phone on them, and actually when ARM started, nobody in the company actually had a mobile phone. Now that seems inconceivable these days. Mobile phones at the time were really big, talk time was measured in minutes, and you had to be pretty brave to carry it around with you. Of course, that has changed immeasurably. Computers are now, or mobile phones, are now much more than devices on which you can just make a phone call. You can now organise your life, organise your social life, do your business. And I bet if most of us in the room here, if we realised we walked out of the house and left our mobile phone behind, we'd absolutely turn around and go back and get it, because without it, your day becomes pretty difficult. The whole is greater than the sum. What's really important about these businesses is what it enables. As I said, mobile phones used to be things that you made phone calls on. They're now much, much more than that. There are ways in which we can communicate and organise our lives, and they're really changing the lives of pretty much everybody on the planet. Once upon a time, mobile phones were only affordable by people with expense accounts who drove big cars, and now mobile phones really are being proliferated around the entire world. There are enough of them built these days for everybody on the planet to have one or two, and we are seeing mobile phones being deployed in developing countries and really changing the way people live for the better. So this industry is huge, and it is changing the way that people interact with the world and with each other. And we think that's a really important thing that is core to ARM's vision. Now, ARM's business is all about partnership. As a company, we pride ourselves for having technology in most of the world's mobile phones. And it's pretty hard to buy a mobile phone that does not contain at least one ARM processor. But what we do is a very small piece of the overall story. ARM is about partnership. It's about enabling our licensees to generate really innovative systems on chips and enable those through innovative device manufacturers to create all of these products that we see in our day-to-day lives. What we focus on is building the core technology, highly energy efficient processors, graphics cores, and implementation IP, which we license to our customers. And we now have over around 300 licensees of our technology, all innovating around our common standard and creating technology that they pass on to their customers to create all of these really cool devices. And what that does is enable a lot of choice. Through ARM's business model, we've lowered the cost of building SoCs that are found in today's devices, and as a result, we're seeing a proliferation of the number of different types of device. What that does is lead to greater differentiation in end products, more choice for consumers, and lower cost. And we think that's a great thing. It enables lots of competition. You know, we're all up for competition, but we think that competition is a good thing because it forces people to innovate, and that results in a better end product for end customers. Today, we're used to this disaggregated world where people do design, other people do manufacturing, people create design tools to enable that whole process. And that's changed a lot in just the 21 years of ARM's existence, but really the roots of that change go back even further. Once upon a time in the 70s, the only companies that made end products were highly integrated. They did everything from design and marketing to manufacturing, and even creating the equipment that they used to do that manufacturing. Through the 80s and 90s, that world changed. We now have ASIC companies, fabulous semiconductor companies, and a key to it is the underlying process technology. Now in Taiwan, that's been a huge part of the local economy, and Taiwan has been a big driver of the disaggregated model that we have today through the creation of the pure play foundry business, which is a really important step. Now, in the disaggregated world, one can argue that there's a disadvantage to this model in that when everybody focuses on their areas of specialism, when you bring the whole together, it leads to some inefficiency or some mismatches in the interface. So we and our partners work really hard to make sure that that doesn't happen. Although through the disaggregated chain, everybody focuses on their area of expertise, we spend a lot of time talking to each other. It's about this partnership model, working out how what I do fits with what you do, which fits with what the guy in the next part of the chain does. And we drive out the risk of inefficiency through the disaggregation and the specialism. And we think we do that pretty effectively. We have many examples of collaborative activities between ARM, our EDA partners, our manufacturing partners, our end customers, software providers, operating system companies, all working together to make sure that the end product, when it comes together, is as optimized as it can be. And what that has led to is the creation of SoCs which have phenomenal capabilities. The transistor count has gone up enormously since the 70s. But we've been able to do that in a way that creates large degrees of efficiency and high productivity for people doing the designs. Because we've done a lot of the work up front, making sure that the products work together, it makes it very easy and lower cost for somebody to build a system, build a chip, build an end product, put the software on top, get to market quickly. That has structurally lowered the cost of developing products for the industry. We think this model is a really important thing, and one which we will remain focused on as we go forwards. Now I mentioned manufacturing. If you go back a few years, you saw lots of people were manufacturing silicon. If you go back about 10 years, there are a number of companies who are doing both design and the manufacture of their end device. Now, one of the problems with every new generation of process technology is it gets more and more complicated, more and more sophisticated, and unfortunately more and more expensive to buy the equipment, to do the process R&D, to put the process together. So that has led to the creation of the specialist pure-play foundry industry, of which Taiwan has been such a cornerstone, and it's led to a reduction in the number of people who actually manufacture silicon. Now that is actually a good thing. Since manufacturing has become so expensive, you get efficiencies when large companies bring economies of scale to a problem like that. And so we see this as a very important step and a very important cornerstone of the entire industry on which ARM is based. So we work very closely with our foundry partners. I personally come to Taiwan on a regular basis to work with our partners here. to make sure that we have a good understanding of what's coming down the pipe in terms of new process technology, and that we can optimize our cores and our processors around those, anticipating the needs of future products. Today we have 32 nanometer, 28 nanometer products shipping. We are doing experimentation right now on next generations of technology. We've done a number of tape-outs of 20 nanometer devices, including using our Cortex A15 core. And we're already working on 14 nanometer tape-outs, 14 nanometer products, which we anticipate will come into production over the next few years. So we have a very efficient business, and what that is leading to is what we call this post-PC era. Now, we've got nothing against PCs. We've all got one. There's one down the front here, in fact, and I've got one in my briefcase. Nothing against them, but they're now playing a part of computing instead of being all of computing. What we're seeing is all of these technologies coming together, enabling people to do things with their computers that once they never could, and carrying them around everywhere they go. You know, I don't particularly like carrying my briefcase everywhere with me. I don't want to have it with me when I go down the shops in case I need to look up the price of something. Having my phone that's in my pocket all the time is far more convenient to me. This is pretty obvious. But what we're seeing is the evolution of these devices leading to some really interesting changes in how people communicate and how people go about their daily lives. So computing is changing. It's gone from something that you do to something that it just is, and it is with you all the time as you go about your life. And we see that as a really, really exciting thing, and I think the next few years are going to see even more fundamental developments in this post-PC era of computing. Exciting times. Now, as I said earlier, we've seen a lot of transformation. That transformation is carrying on and is going faster and faster than we've ever had before. Phones used to have their talk time measured in minutes. We're now talking about video playback time in hours. What's changing is user interfaces and the bandwidth of data that you can get into a device, and then the processing capability of that device. As all of that comes together, and we put that in the hands of developers who can build upon open standards, we see more and more creation of new devices. What's great about all of these devices are people are able to work out things to do with them that nobody could think of whilst they were being designed. If you think about a smartphone today, it has some hardware in it, it has an operating system, it has open interfaces to that hardware, and what that means is developers, thousands of them around the world, who weren't involved in the design process in the first place, can take that technology and run with it. They can work out the best thing to do, the best application, the best way of using all of these resources in the phone, in the handset, and come up with new creative applications. And it's that makes this industry, for me, one of the really, really interesting things. The fact that people can innovate around this platform that weren't involved in its design process means that thousands of brains across the world can be put to evolving these products and thinking up new uses. That is really, really exciting. Shown on this slide are 5 of the key areas in which we are innovating around ARM technology. The Cortex brand there is the name of our processors. We have a range of Cortex application processors, the largest portfolio of an IP licensing company in the industry, ranging from multi-gigahertz processors to really, really tiny, small processors that can be embedded into pretty much anything. Sitting alongside that are our graphics cores. We call them our Mali graphics cores. Many of the devices that ARM gets designed into these days are becoming more and more graphical, generating the graphical displays can be very power hungry, very area hungry in terms of silicon real estate. So we're working very hard on the efficiency of graphics cores to sit alongside our processors. Hooking all of that together is our calling technology. Now, modern SoCs move a lot of data around within the chip, and you can do that in an inefficient way, or you can do that in an efficient way. We're obviously working to make that as efficient, since the data bandwidth on chip is going up and up. That chip needs to be realized in silicon, and our artisan physical IP is all about how you take your design and actually have it manufactured. So through working with our semiconductor foundry partners, we create libraries of products to enable the system design to actually be realized on a silicon wafer in a very high performance, power efficient way. And then applications that run on top of that increasingly are becoming security aware. So we have a security architecture called Trust Zone, which extends deep into the processor core itself, and then up into the software in a coherent way that allows secure systems to be built on top. So these are 5 areas of what we in ARM are focusing on as future technology drivers. Behind that, you see some diagrams there of what we call the connected community. ARM is nothing without its partnership. The connected community is about over 900 companies working with ARM and with each other to provide a complete ecosystem to support the design of an ARM-based SoC. If you're a designer at your desk and you need help with either doing the chip design itself, you need some consulting expertise, you need some tools, you need some software, you need an operating system, there is somebody in the connected community who can help you do that. It's a large ecosystem. We treat this with high importance within ARM. We want to see that be successful. We want to see our partners within the connected community run profitable businesses because it's a very, very important thing for the proliferation of ARM technology. So that's what we are doing, and that's how we're working with our partners. What that's leading to is a high rate of evolution of the end device. What's shown here on the lower half of the screen here is just some of the devices coming out from some of our partners. And what's incredible when you draw it like this is the rate of change of device. Once upon a time, the PC industry had a kind of annual clock tick where new machines came out and they were as big, grand, ugly as they were the year before, pretty much. What we're seeing now is a rapid change of the number of devices being created by our partners, enabling a rapid change in the technologies that the end device can utilize. It doesn't seem that long ago that 720p video was the state of the art on a handset. Now we have multiple streams of 1080p, we're seeing 2K displays starting to emerge, more and more graphical content, more and more video. And this is a continuum. We've shown a snapshot here of a few years, but there are more and more technologies coming out, more and more user interface styles, gesture recognition, voice control that actually works. Lots of different ways are emerging to interface with your device to help you utilize it and make yourself and your device more and more efficient. So the rate of evolution is phenomenal, and it's just creating a lot of choice. You can see there are lots of different devices there. Single core, multi-core, quad-core, enabling different styles of implementation in the end device. Now, multi-core is a really important part of the processing story for mobile devices as we go forwards. Multi-core is important not just because you want one next year that had more cores in it last year. The actual underlying technology is a really important facet of how we control power and deliver high performance. Everybody needs more performance. The problem is if you stick a big single-threaded CPU into a mobile phone, your battery is not going to last very long. The thing about mobile phones is it's really important to understand the context in which they are used. You don't need full performance all the time. Most of the time, you don't need much performance at all, in fact. But when you do need it, you want it. And so multi-core is a great way of allowing you to scale up the amount of performance that you have and scale down the amount of power you're consuming depending on the application that you're actually running at any one moment in time. So multi-core devices, really, really important. We're showing here an example of a dual-core versus a single Cortex-A9. The single-core Cortex-A9 has a maximum performance it can ever run. With the dual-core, we have the flexibility to lower the power when we don't need all the performance, provide the performance when we need it. And you will see devices coming out with more and more cores, and not just all those cores being the same. You will see big high-performance cores, and you will see really small power-efficient cores. We call this architecture big. LITTLE, and it's an important part of the way we are driving power out of mobile devices. You will also see a mixture of cores. Not all the cores will be CPUs, there will be some GPUs, there will be video accelerators. What we call heterogeneous multi-core devices are going to become commonplace in handheld devices because it is the way in which you can deliver high performance but low power at the same time. So multi-core, very important part. And the uptake of multi-core has been quite phenomenal. In the last 2 years, almost every major silicon manufacturer has adopted multi-core. And I think in 2011, something like 25% of all smartphones utilise multi-core SoCs. Multi-core is the way to go. You're going to see more of that going forward. And it isn't just marketing, it's about how you deliver high performance with very low power. Now we think of mobile phones as being completely ubiquitous, but it's interesting to look that it took more than a decade for mobile phone usage to exceed 10% of the population in the US. Now this is just US data. Smartphones, which added more functionality, more utility, hit that 10% point after about 6 or 7 years, much quicker. Then tablets achieved that in a remarkably short space of time, less than 2 years, to achieve 10% penetration within the United States. United States, big market, but not as big as the rest of the world, and in fact the developing world represents an enormous opportunity for mobile devices. And in fact, over 70% of all mobile subscriptions are in developing countries. Now, some of these devices are never going to be successful in developing countries because they're not designed at a price point to be suitable there. But what we're seeing through the utilisation of standardised ARM technology, standardised operating systems, is people are able to produce handsets and even tablets at a price point which are suitable for developing countries. And we anticipate a big uptick in volumes as a result of people taking advantage of that big market opportunity. Now, tablets build on all that ecosystem that came from phones and smartphones. We see tablet as a big opportunity for computing generally for the future. Tablets, particularly smartphones, aren't just about consumers, they're about business as well. What's been interesting over the last couple of years is how people in the workplace are choosing to go with a tablet instead of a conventional PC or a laptop, and people are in fact bringing their own devices to work. There's this big theme about BYOD, bring your own device, which has caused a bit of heartburn for your average IT manager as he deals with the fact that, well, it's yours, it's not mine, I can give it to you. How do I set up the security around that to make sure that you don't inadvertently violate my IT infrastructure? But CIOs are responding to this. This is a trend that is going to happen. The tablets, the smartphones provide so much utility. It's such a convenient form factor that this trend towards using these kind of devices in the workplace is just set to grow and grow and grow. You can see here some of the data about plans to deploy mobile technology in the workplace and how conventional computers are being replaced in large numbers. Big opportunity here in the workplace. The other thing that's interesting to look at is how, as we go forwards, we're not seeing just a one-size-fits-all mentality to mobile devices. Computers are all big, grey and ugly, as I said, and laptops are all pretty much the same. In mobile devices, you just see a huge, diverse number and different types of end devices suitable for different markets. There's very high performance devices, there are some very lower performance devices, again utilising all those common standards, leveraging all the back-end applications, but at a much lower price point. And we see that across the spectrum, approximately an order of magnitude growth in volume shipments of devices, in both tablets, in smartphones. Smartphones are going to span into different performance and price points. So, but what's enabling that are all those different SoCs you saw on one of the earlier slides. Different devices tuned for different price and performance points, enabling diversification in the end product that is shipped to consumers, giving us all choice, and that choice is a good thing. But actually there is a growing market in low-cost tablets. The official number that Gartner will produce says that there was about 17 million tablets shipped last year. We believe the number's closer to 25 million based on our own analysis. And that difference, those 8 million devices, are low-cost devices from companies most of us have never heard of, that maybe don't even have the company name on the device, selling at a very low price point. And we're seeing a number of our SoC partners creating devices specifically for this market, which we think is going to double over the next year. I happened to have a look on Amazon.com last night at low-cost Android tablets, and I stopped counting when I got to 20 that I could buy today for less than $100. So when people think about tablets, they're thinking $500 and up. There is a large market today, and that is growing for these very low-cost tablet devices, which are really good machines. We were playing with some of them last week when I was in the UK, and they are great devices that do everything that most people need. So there's a big market here for low-cost devices, and we're seeing a number of our partners target that using our Cortex A9 processor, using our Mali graphics core, the standard components that you're going to see in lots and lots of these devices. That really has become this kind of de facto standard for the low-cost tablet SoC. Now, it's not just about computers that have a kind of a user interface that you access the web through. There are many other types of computer that are enabled by this technology. Many small form factor devices on USB sticks or small PCBs that can bring computing in different ways. One of the things that's shown here is the Raspberry Pi. That is this little board here. And this is a device that some engineers have put together and created a foundation around, a non-profit foundation servicing educational needs. Really small device, runs Linux. You can do a lot of desktop-style processing, just like you would do with a big old PC, but on a board that's about this big, and you can buy for $35. Phenomenal capability in a really low price point. And no matter what you're doing, what performance point you want to hit, what kind of end application you have, there is a stick or a board there running Linux that you can use in your own device. Now, as I said, computing has gone from something that you do to something that is just that just is and is around you all the time. And we're seeing more and more devices increase the amount of processing power that they have within them. Now, TVs are obviously digital devices and have really turned themselves into what at one level look like mobile phones but with really big screens. They have data that comes into them at a fast rate. They have a big screen. They run an operating system like Android or Linux, and they provide downloadable applications. Sounds a bit like a smartphone, but obviously it's quite large, and we have one over there. You're not going to put that in your back pocket when you walk out of the room. Please don't try that. So TVs growing in their digital content, growing in their processing capability. You'll see many screens on display here at the show this week, I'm sure, with dual-core processors and graphics cores going to multi-core graphics as well. Cameras, obviously cameras went digital a long time ago, but the amount of compute power in those is going up and up as well, providing functions such as in-camera processing of the image, things say HDR or exposure correction, and also GPS and Wi-Fi to work out where you are and then upload your images to your favorite photo sharing site. Set-top boxes are becoming kind of media hubs, again with high-performance processors in them, connecting data to a screen, a common theme there. And devices like printers are becoming internet connected. And one of the benefits of that is it allows us to do away with printer drivers because we can print via the cloud and it just works. So computing is all of that compute power is finding a way to make your life a bit easier, because let's face it, who hasn't struggled with a print driver that didn't work on their PC? It'd be a great day if that disappeared. And through further compute power and a device like that, it can. So we're seeing just the amount of compute power in these devices going up and up and up. Huge opportunity, a great opportunity for ARM's low power, low cost silicon partners. And in even further embedded devices, we're seeing more compute power going to just everything. Every walk of life is benefiting from more compute power. Things like digital signage, when you actually go and buy something at the point of sale and they swipe a credit card. More compute power in that is allowing for a higher bandwidth, so quicker transaction time, and greater, more secure transaction. So lots and lots of computers are just getting embedded in and around the world. Everywhere that you interact with is going to have a computer. And people are working on standards for how to make that more effective, more cost effective. So we have here an example of an organisation put together to create some standards around small form factor ARM powered devices. There's a form factor called ULP-COM, specifically set up by that group of companies shown on the slide there, to target a standardization to allow boards to be built in a plug-and-play way so the software can be installed and people get to market more quickly. So computing going everywhere, even into deeply embedded devices. Now, what all of these markets have benefited from is ARM's DNA, which is about low power, low cost, and business model. And one area where a lot of people thought that would never apply to is in fact servers, but it is applying to that as well, and we're starting to see the fruits of that. By bringing together low power processing with high performance, by enabling that to be integrated with lots of other functionality. In the case of a server, it's all about the interconnect fabric. By putting that all onto an SoC, you can create a very low cost, processor that can be integrated into a server, replicated by the millions, and provide a lot of compute power. On top of that, you need to run software, and there's a lot of software activity going on around that. We have our friends from Ubuntu here who can show you some of that today. And in one of the keynotes tomorrow, my colleague Ian Ferguson will be talking about that in some more detail, so I encourage you to join. We've seen announcements from Dell and HP around silicon from our partners shown here, Applied Micro, Texas Instruments, Calxeda, Marvell, all of whom are bringing machines to market. Servers based on ARM. A few years ago, people thought that was science fiction, but it is happening, and it's leveraging all of that expertise and industry structure that's enabled mobile computing into a server that's going to radically lower power, make the delivery of the cloud a more efficient thing. So, lots of opportunities in different markets, everything from deeply embedded, really small, really low-cost chips to mobile phones and tablets and servers. All of that is delivered through partnership, and as I said right at the beginning, ARM is all about partnership. We can't do everything ourselves, and from day one in the company, I've been with the company since almost day one, we recognise that we're going to have to build a huge partnership base to make this happen. We have done that, and the partnership is enabling this compute power in an industry-efficient way. We're going to hear now from a couple of our partners who are going to talk about that.
The ARM architecture enables us to successfully address multiple markets with right-sized computing scaling all the way from mobile to tablet to even node PC.
The ARM ecosystem is at the heart of this mobile computing revolution. Together with ARM, we are reshaping digital lifestyles now and into the future.
Through the partnership with ARM and being part of its ecosystem, we can foresee the new level revolution of computing technology that we will work together to enhance and enrich everyone's life.
ARM is clearly the instruction set architecture of mobile. All development of mobile is done on ARM. And they continue to focus on power efficiency. You get a little more performance every time for the same power.
我们跟 ARM 的这种合作呢，我们是把 ARM 的一些初期的这种优势的技术应用在华为的这种硬件中来，应用华为的芯片中来。同时呢，提升这个移动互联网的这种体验的这种性能，包括它的这种速度、运算速度，包括它的省电，所以让这个核心运算这个能力呢能发挥到极致，能够让用户的体验能够上一个很大的台阶。
ARM ecosystem gives us the power to innovate and differentiate. We can give people powerful mobile experiences that fit their individual needs.
Well, I think if you're trying to develop solutions that scale from cubic millimeter through to a cubic kilometer and to address the market of tens of billions of different chips, the only way to do that is with partnership, because no one company can scale across that diversity of hardware, software, system design. The whole complexity means that partnership's the only business model that works.
So as my colleague Michael has said there, it's all about partnership. I think here at Computex this week, you're going to see some great examples of what that partnership has delivered. There are going to be lots of really cool devices on the floor for you to see, and that really provides a snapshot of what the last few years of innovation has brought, and will give a glimpse into the future for what the next few years is going to bring. We strongly believe in that partnership. It's going to deliver some really cool devices in this post-PC era. And I hope you have a great time this week at Computex. We're really excited to be here. And with that, I'm going to hand back to Irene. Thank you for your attention.
Thank you very much, Simon, for your thorough presentation. Thank you again. Please remain on the stage, and then I would like now invite Graham on the stage as well. And we're going to open the floor for question and answers. We do have our colleagues Roy here and Ivan here to help out. 如果你需要做
We expect, as well as bringing Windows to product form factors like tablets, it's going to enable ARM-based products to be used in the PC domain as well. So we're really excited about that. And we're expecting to see very really ultra thin form factor EC type products. For example, we're expecting to see really the lowest power consumption of those kind of products, just delivering a really compelling user experience.
Those are heavily developing country. So the journalist asks whether this is the result of the development.
Well, I think the Lenaro Consortium has delivered, pretty much delivered on its objectives of pooling together resource from around the ARM partnership that was already doing the same thing. We were getting a lot of repetition going on in lots of our partners, so bringing that all together to really focus on providing a very compelling Linux experience, kernel optimizations, tools, and the Lenaro Consortium seems to be doing very well in that regard. So we're happy with the progress they've made, and some of the examples that we've seen here clearly benefit from that common effort around Linux optimization.
Operating systems. Can you give us some ideas on how you think ARM will stack up? So far ARM is dominant in its key areas, but do you think that going forward a few years from now we'll see more ARM-based WinAC devices, for example on the tablet side than x86? Or do you think it'll be 50-50, or maybe x86 will have a little more of the market share? How do you see that will be played out?
So I think, well, in terms of market share, I think we're going to continue to see ARM-based tablets taking the strongest share there. But you were asking about x86 compared with ARM and how that's going to play out. And one of the things you've got to remember here is that today the products based on the x86 architecture are a generation or two behind where the products based on the ARM architecture are. And we're not standing still. We are continuing to innovate. We're continuing to create new products. Simon was mentioning in his speech about Big Little, for example. Innovation is needed in order to create the compelling products of tomorrow. Innovation is needed across many areas of the SoC design, and you can expect to see new product from ARM this year, next year, the following year. We're continuing to innovate, continuing to drive our roadmaps to make sure that we stay ahead.
Tend to adopt the leading edge technology as quickly as they can. So I suspect that the uptake will be quite aggressive, and that some of our leading SoC partners will look to utilize 20nm technology just as soon as they can and ramp that up. With a quad-core device, obviously there's a lot of transistors, and so building on the smallest geometry you can is good for keeping the area as small as possible. So I think you'll see people migrate to that small node as quickly as they can in those multi-core devices.
And the second question is that for 14nm, is Cortex A15 still the technology for 14nm technology, or will there be a new core announced by the time of 14nm?
I think by the time that 14nm makes it into production, we will have inevitably introduced new processors from ARM. If you look at the kind of cadence of our new product announcements, and you think about the timing of 14, if we haven't announced new products by then, I'd be very surprised and frankly a little bit worried by it. So I would expect that we do. When we design a new processor, we aren't thinking, oh, this core will be the one that is built on this particular node and no others. And many of our processors migrate from one geometry to the next. The first product from ARM that really shipped in a lot of volume was ARM 7. That was built on half-micron technology originally, and that is being ported to 20nm today. So our products have a very long lifetime and migrate from one process node to the next.
Okay. So the third question is that about the foundry strategy. Currently, ARM has a very close relation with TSMC. So in the future, what's our function stage will then be changed to the function stage strategies?
So really our strategy is around enabling the best manufacturing for the ARM partners, ARM partnership in general. You mentioned TSMC being very aggressive on advanced nodes, and that's why we want to work with them to make sure that that technology is as best suited for ARM SoCs as possible. So, you know, that really is our strategy, to make sure that the best leading edge technology can be applied by ARM's partners to make the best ARM SoC that we possibly can. And I don't see that changing over time.
Have had issues meeting the demand. How realistic is your expectation for 20 nanometers in 2013?
Well, I think you know, in terms of any issue that may or may not be there, you're better off having a conversation with those partners. But you know, I can say that the industry as a whole remains focused on moving to the next generation as quickly as economically viable and technically achievable, and those two things have to go hand in hand. But as I look at 20 nanometers, lots of demand around that right now. As multi-cores get more cores, there's more graphics cores. There's just demand to put more transistors in a chip, and if you can migrate that to a smaller geometry, then that becomes more cost-effective. I mean, that's really been the effect that's driven the semiconductor industry for a long time now, and I don't see any change in that.
Plan for a common server interconnect, or is that up to the partners and they do their own best interconnect wins? And sort of related to that, anything on AMD and the common bus? It's announced.
Okay, so I'd say no update on the latter then. And on the former, right now we're focusing around our cores. We haven't announced anything about common interconnect. The reason that we partner successfully with our customers is because we don't try and do their job. Right now there's a whole lot of expertise around putting server chips together that ARM does not have, and that's why we go work with people, and that's what they do. That's the value that we bring, it's the value that they bring, and that's why the partnership is successful. 3 countries. I have 3 children, and I love them.
Just describe what's their advantage and weakness, and how they are spatial in different areas. I would like to know that, because it's very valuable for our Taiwan design team or our industry to know how different we are than the others.
Yeah, personally, I don't really think you can make the comparison on a sort of country by country level. I mean, every company is different. Every company has its own unique strengths and brings its own differentiation. And that's equally true within Korea, Taiwan, China.
Or I give my question very directly to compare with Samsung. What's their advantage? Because every day when we visit people in this industry, all they give me the keyword is Samsung. So why they mention Samsung so much? Because they give us a big pressure. So I would like to know at your side, because you will cooperate with them very closely. So give us some advice. How do you think Samsung, or how you feel we could learn or we could compete with Samsung for the industry? This question is for our industry.
One of the interesting things about Samsung is that they do make use of a very wide range of IP from ARM. I mean, actually, pretty much everything that we create.
Okay, so Graham probably tried to hint that